Hi everyone, my name is Evan Barnes and I am part of Washington State University's School of the Environment. Within this presentation, we will take some time to cover numerous aspects of Kamiak Butte, such as what geologic events unfolded during its creation, what type of climate affects the butte, the differing biomes of Kamiak Butte and their plant communities, and the Native American influence over the Palouse and Kamiak Butte. Come along and join me as we take an ecological journey exploring the ins and outs of Eastern Washington's crown jewel, Kamiak Butte. The basaltic flows from Tobalchik volcano complex in Kamchatka, Russia provides us with a glimpse into what southeastern Washington and northern Oregon very well could have looked like during the formation of the region known as the Palouse, when the Columbia River basalts were spewed from the Earth's crust. Spanning from roughly 16.7 million years ago to 6 million years ago, the Columbia River basalts quite literally paved the way for the creation of the Palouse. Covering roughly 163,700 square miles of land in a whopping 174,300 cubic kilometers of basalt, the Columbia River basalt spewed 99% of its magma within its first 2 million years, reaching upwards of 3 miles thick in some areas. Now, you may be asking yourself, what was the causation behind these volcanic events that led to the spewing of basalt onto Earth's surface at this time? Well, the short answer is Yellowstone. It is hypothesized that 16.7 million years ago, around the same time when the Columbia River basalt began, the Yellowstone hotspot resided in the area consisting of the Nevada, Idaho, and Oregon borders within the McDermott volcanic field. It is thought that this hotspot formed and heated through the crust in eastern Oregon, creating a large reservoir of magma that eventually grew until it erupted in weak spots of the Earth's crust known as fissures. Multiple rock supergroups throughout the state survived these basaltic flows, however. This is because prior to the eruptions, they were large, towering mountains whose peaks could reach further than the depth of the basalt flows. As the eruptions occurred, the bottom parts of the mountains became buried while the peaks remained above the flows. This resulted in multiple buttes located throughout the state, Kamiak Butte and Steptoe Butte being examples. 3.5 million years after the Columbia River basalt subsided, the Earth began to start the glaciation period known as the Ice Age. During this time, large glaciers creeped their way through North America from the North Pole, eventually making their way to the northern portions of Washington and Idaho State. 11,700 years ago, however, the Earth began warming as it left its period of glaciation. As the Earth warmed, ocean water began to evaporate and accumulate in the sky as clouds. These clouds would precipitate as rain and snow onto the now warmer Earth in places that would naturally have lakes, rivers, and other bodies of water. These bodies of water began channeling through the glaciers and combining to create more rivers, lakes, and other bodies of water. Eventually, however, these flows of water met an impasse, a glacial lobe located on the Clark Fork River, which blocked the flow's passage, forming the glacial lake known as Lake Missoula. Over time, the water of Lake Missoula began to undercut the ice until it eventually broke through the dam, destroying the glacial lobe and absolutely flooding the Pend Oreille Valley in its entirety, carrying boulders, ice, and soil across the Pacific Northwest. This water and debris, which were estimated to travel at upwards of 80 miles per hour, made their way from the Pend Oreille Valley down the Columbia River to then spread across the landscape, etching new waterways and depositing debris in every direction that it traveled. This created many natural formations across Washington, such as what is known today as the Scablands, for example. Throughout the end of the Ice Age, Lake Missoula would freeze and flood multiple times, creating channels for flow each time that it flooded and creating the landscape of the Pacific Northwest that we all know today. Each time Lake Missoula would flood, it would pick up large amounts of sediment, ice, and organic matter in its path from Montana to the Pacific Ocean. The natural pathway of these floods came to a halt at Wallula Gap, located in southeastern Washington. Here, Wallula Gap largely constricted the flow of water and the debris that it carried. This resulted in the formation of a dam within Wallula Gap due to the massive amounts of debris, and as a result, Lake Lewis was formed. As the fast-moving water of the Missoula floods became stagnant as they entered Lake Lewis, the sediments that they carried would eventually settle to the bottom of the lake, forming a nutrient-rich mud. When the dam at Wallula Gap burst, the water was able to escape, but the newly settled sediment remained where it was deposited. Over time, this nutrient-rich sediment was blown up the Columbia Valley by wind currents and eventually deposited throughout the Palouse as loess. The combination of nutrient-rich loess on top of the non-porous basalt created a pristine land for farming and agriculture, since the basalt prevents precipitation from quickly leaching away nutrients from plants before they can sequester them into their roots. For this same reason, however, Kamiak Butte cannot be farmed on, as its very porous quartzite rock layer allows water and nutrients to leach away very quickly before plants with small root systems can uptake them. Kamiak Butte's climate consists of a marine, modified continental macroclimate. It is under the direct influence of maritime polar air masses, which are air masses formed near the North Pole that traverse over the ocean and pick up moisture along the way. These air masses are typically cool and most often bring cloudy, damp weather to the United States, hence why Seattle, located directly on the western coast of Washington, is always cold and wet. Cloudy and damp? That doesn't sound like the Palouse though. Although Kamiak Butte and the Palouse are under the effect of the same air masses as the western part of the state, they appear to be from two separate worlds. This is due to what is known as rain shadow, which is caused by differing topographical influences throughout a landscape. Topographical features, mountain ranges specifically, are important in determining climate due to the amount of power that they hold in controlling and manipulating natural environmental forces. Mountains play a large role in precipitation and wind patterns. When a moving air mass comes in contact with a mountain range, they are forced uphill, which cools the air and forces the water vapor in it to condense and fall as what is known as orographic precipitation, or precipitation that occurs when an air mass meets a topographic feature. As orographic precipitation occurs, it drains air masses of their moisture. In the case of a mountain range, once an air mass has crested over the peak, most of its moisture has been precipitated, resulting in it becoming a much drier air mass than it was when it first met the mountain range. Once the air mass drops down the opposite side of the mountain range, it begins to warm and become able to hold massive amounts of water vapor. This newly warm, dry air mass leads to massive amounts of evaporation in areas below it, resulting in a much drier climate on the opposite side of the mountain range versus the side that comes in contact with the wind. This effect is known as rain shadow. This process is exactly what occurs when maritime polar air masses come into contact with the Cascade Mountain Range on the western part of Washington, resulting in a very wet western portion but a very dry and arid eastern portion. Continentality has a lot to do with determining the climate of an area as well. To put it in short terms, continentality is the relationship in distance that a location has from its nearest ocean or largest body of water. Comparative with land, water has a much larger heat capacity, meaning that it can hold much more solar energy than land and has a much smaller range of temperature variations throughout the year. Because of the amount of energy they hold, oceans are large energy sinks that lead to the initiation of air masses that control weather and climate. When these air masses first come in contact with a continent, they are full of energy and have a large moderating effect on the local climate by dumping steady, large amounts of precipitation. The further inland they move, however, these air masses come in contact with differing landscapes and topographies that drastically reduce their precipitation energy as they traverse a continent, the further away from an ocean that they get. This causes them to lose their moderating effects, leading to a more drastic range of temperature and precipitation variation the further inland you observe. This effect is evident at Kamiak Butte, whose average temperatures throughout the year fluctuate by roughly 60 degrees Fahrenheit. The wondrous climate of Kamiak Butte and all the factors that converge for its formation are what help dictate the biomes that occur at Kamiak Butte. Kamiak Butte is somewhat of an anomaly, however, with its biomes because it is under the influence of two, the western interior shrubland on the southern aspect and the western interior woodland on the northern aspect. The causation of this separation of biomes between the two aspects can be closely attributed to one single variable, the delivery of solar radiation. On the southern aspect of Kamiak Butte, photosynthetically active radiation becomes readily and steadily available early in the spring due to the direction it faces in relation to the sun. This occurs before new and young plants can become fully established within the soil and is extremely detrimental to plant communities. This early increase in solar radiation puts a large increase on the amount of stress that plant communities on the southern aspect receive, resulting in sparse amounts of growth in the overstory community and a large lack of an understory community. The northern aspect of Kamiak Butte differs immensely from the southern aspect, however, and that can be attributed to the differing amounts of solar radiation that it receives. Being a northern-facing slope in the northern hemisphere, the northern aspect receives less sunlight than its southern counterpart, due to the angle that sunlight strikes the planet. Since the northern aspect is not being constantly bombarded with intense solar radiation for the entirety of the growing season, vegetation has been able to grow and thrive. This has resulted in a thick, densely populated forest full of coniferous trees in the overstory and lush growth in the understory community. This drone footage, provided by Aidan Amel of Washington State University's School of the Environment, illustrates the vast differences between the vegetative landscapes of the north and south aspects. Observe and notice that the northern aspect is mottled with trees, bushes, and shrubs. The southern aspect, on the other hand, has a noticeable difference from the northern aspect. What do you see that differs vastly from the northern aspect? If you said plant species that inhabit each side, then you're on the right track. As shown in the drone footage, the northern aspect is comprised of a lush vegetative community, which results in large amounts of organic matter or humus to be deposited back into the soil each and every year. This humus is crucial in the continual survival of the northern aspect, as it becomes decomposed into the soil and fixed into a form of nitrogen that plants can uptake and utilize for photosynthesis. Along with this, the humus retains large amounts of water that would normally leach its way into the quartzite away from plants. The retention of water provides hydration for the plant communities that live on the northern aspect and allows for them to thrive. As overstory communities thrive, they provide ample crown coverage for the understory communities below, making large amounts of vegetation a possibility, thus completing the cycle. On the northern aspect, there are 172 trees per acre on average, with 88% being comprised of Douglas fir, 6% being comprised of western larch, and the other 6% being comprised of ponderosa pine. The average DBH, or diameter at breast height, on this aspect is 19.4 inches, and the average height of trees are 97 feet. The plants that live in the understory community and contribute to this humus each year are mallow ninebark, common snowberry, ocean spray, mock orange, elk sedge, and blue elder, while the overstory community is dominated by ponderosa pines, Douglas firs, and western larch. Due to the amounts of solar radiation that the southern aspect receives, it has been quite hard for an overstory community to develop. Because of this, there are very limited amounts of shade present on the southern aspect, which has made it almost impossible for any sort of understory community to take hold. Aside from blue bunch wheatgrass, North Africa grass, and other bunch grasses native to the Palouse. Without the presence of an understory community, there is a very limited amount of humus that returns nutrients back into the soil of the southern aspect. This has created a very nutrient-poor soil, which has made the amount of growth that does occur there very limited each year. This is evident in the lacking overstory community, which has an average of 35 trees per acre, with 100% of these trees being comprised of only ponderosa pines. On the southern aspect, the average diameter at breast height is only 17 inches, and the average height is a mere 40 feet, which is much smaller than that of the northern aspect. Now that we're done with the science behind Kamiak Butte, let's delve into the cultural history. Kamiak Butte was named after a very notable and respected Native American chief in the 1800s, Chief Kamiak of the Yakima tribe. Born from a Palouse father and a Yakima mother, Kamiak was very influential amongst both of these tribes, whom of which were very significant at the time. The Palouse tribe were a nomadic group of natives who spoke the language of Sahaptin, a dialect of the Plateau Penutian language. They would traverse the eastern part of Washington, following sources of food as seasons changed. These seasonal rounds would include wintering in the Kittitas and Antonum valleys, in the spring harvesting roots planted on nearby prairies, salmon fishing on the Columbia, Wenatchee, Snake, and Spokane rivers in the summer, and harvesting berries from fields maintained high in the Cascades during the fall. The Palouse divided themselves into three bands, the upper, middle, and lower. They were also widely known for the breeding and domestication of the Appaloosa horse, which gained its name from the tribe that first tamed them. The Yakima tribe were a much larger tribe than the Palouse, who also spoke Sahaptin. Very much like the Palouse, they were nomadic people who would live off the land. The Yakima would hunt numerous species of animals, but specialized in fishing for salmon, sturgeon, steelhead, and trout. Their leader, Chief Kamiak, was an extremely influential leader throughout the Native American tribes that are spread throughout Washington state. He played a crucial role in the Yakima Indian Wars, which were an attempt by the Yakima tribe and 13 others to resist the U.S. forces from clearing Washington territory for prospectors and settlers in 1855. What spurred the beginning of the Yakima Indian Wars was in 1855, a rumor spread amongst tribes within Washington that Governor Isaac Stevens had made a plan to purchase tribal lands from each tribe, and if they refused, he'd simply take it by any means necessary. As a preemptive strike, Chief Kamiak used his influence and connections with each of the tribes throughout the state of Washington and Oregon to convene and form a multi-tribe council to discuss a unified strategy to take on the United States government. After convening, the council decided that they would meet with Stevens in Walla Walla and hear what he would have to say, but refused to sell any of their land whatsoever. This plan fell apart rather quickly, however, as many Nez Perce decided last second that they would pursue their own strategy. The council with Governor Stevens went on for days, and one by one, the chiefs began signing over their land as they had no other choice. An interpreter for Chief Kamiak by the name of Andrew Pambrin is quoted to have stated that Governor Stevens told the chiefs that you will walk in blood knee-deep if they did not sign the treaty. Eventually, Kamiak decided that he had no other option but to sign the treaty, and Pambrin was quoted again to have said that Chief Kamiak was in such a rage that he bit his lips until they bled profusely as he signed an X for his signature on the treaty. Within the terms of the treaty signed, the Native Americans were supposed to have been given ample time to gather their people and belongings and move to the provided reservations that Governor Stevens had set aside for them, but that sadly was not the case. In as little as 2 weeks, the discovery of gold in the Columbia Basin prompted miners to show up, which was a direct violation of the agreed-upon treaty. This sparked a gruesome 3 years of war with multiple bloody battles occurring between Washington and Oregon Native American tribes and the United States government. These battles culminated into what was known as the decisive Battle of the Spokane Plains. As expected, the primitive weapons of the Native Americans were no match for the advanced weaponry of the United States soldiers, and massive amounts of bloodshed occurred. At one point, even, a howitzer shell struck a pine tree overhead of Chief Kamiak, and a falling limb struck him from his horse, severely injuring him. If it wasn't for his wife at the time helping him evacuate to the family camp on the Spokane River, he surely would have succumbed to his injuries. The natives were forced to retreat from this battle, and the United States government demanded that Kamiak and other leaders came to their camp and surrender the war. Chief Kamiak never showed up to formally surrender, but the two other chiefs did and were soon both executed, one hung and one shot trying to escape. This gruesome story is just one of many that were written in the Palouse. Although the Native American forces were bested on that day, Chief Kamiak's legacy lives on eternally at Kamiak Butte, which was named after him in his honor. That is all I have for today. I would like to thank you immensely for taking the time to listen to my presentation. Once again, I'm Evan Barnes from the Washington State School of the Environment. Thanks.